Hello everyone. If you are looking for your notes, remember that from Tuesday you're going to be using that same document for the next few weeks when we talk about transformations. So we already talked about translations. So now we're going to focus on reflections. These are a little bit less time consuming in the sense of the notes. So reflection is a flip or a reflection. So it's kind of like a mirror image, and we reflect it across what we call the line of reflection. So typically when we do our line of reflection, we're talking about the X or the Y axis. It creates a mirror image. Reflections do not change shape or size. So they remain the exact same shape and the exact same size, and they also do not turn or slide. So we cannot have it moving left, right, up, or down. All it is flipping over the axis of symmetry or line of reflection. So when we are looking at example 1 here, in case determined if the figure 2 is a reflection of figure 1 over the given line. So this is our given line, and what happened is that it flipped down. This right here is exactly the same distance as it is below. So this is equal distance from our reflection line. So since that is the case and it's the exact same image, same shape, same size, didn't slide, didn't turn, yes, this is a reflection. And remember that you should be writing your own notes as well. So if you need to use your dual screen and share it, that's completely fine. Or put the video down in the bottom corner and be able to write your own notes. And this is because it's still the same shape. All right. So now when we look at letter B here, this image right here is a shape. To get to this image over here, it would have to flip over it, which would mean that this side right here would have to be right here. And it is not. What happened is it actually slid over. So it actually performed a translation. So for this, we're going to say no. This is a translation. Okay. So when I have this discussion question down here, does applying a reflection to a pre-image produce a congruent final image? So you need to write here, does it produce a congruent image or not? Well, we know that it does because we learned last time the word congruent means same shape, same size. Could be in a different location. It could also be flipped, but it is still remaining congruent. So make sure you write that there. All right, so here we are going to perform reflections on the coordinate plane provided here. So we are going to reflect either over the x-axis or the y-axis, and that will be our line of reflection. We're going to follow the directions below to practice reflections on the coordinate plane. Plot the point 1, 3. This is the pre-image. So I'm going to plot the point 1, 3. And I'm going to do that in this pinkish color. So I'm going to go to the right one and up 3. This is my pre-image. This is point number 1. So that is why I labeled it point number 1. The next thing is that we are going to move on to part 2. It says reflect this point over the x-axis. Plot the new point on the plane above, and what are the new coordinates of the point? Okay, so I'm going to change colors here, and I'm going to go with a light blue, and I'm going to reflect point number 1 over this x-axis. So this blue line that I just drew there, I am going to make this come down here. It needs to flip over. So in order for the image to remain the same, I have to have the exact same distance of 1 from the x-axis as I do for point 2 from the x-axis just below. So I notice that this is 1, 2, 3 spaces above the x-axis. So I need to make sure my second point is 3 spaces below the x-axis. So when I did that, I now have the new point of positive 1, because my x always comes first. This is my x, this is my y. And then my y value is negative 3. Now I'm going to change colors again, and I'm going to reflect the point 1, 3, my original 1, to go across the y-axis this time. So our y-axis is this vertical axis. So it is the one that goes up and down. So now I notice that my 1 needs to come over to this side of the y-axis. So in order to flip it or reflect, I notice that my original point, 1, 3, is only 1 away from the y. So when I plot it over on the left side of the y-axis, I make sure it is exactly 1 away as well from our y-axis or our line of reflection. So now my new ordered pair, my x changed to negative 1, but my y value is still at positive 3. Okay. So down here it says, for a discussion question, what could be a general form of symbolic representation for a reflection over the x-axis? Answer below and explain your thinking. So go ahead and write something there. I'm going to show you what the symbolic representation actually is, but if you remember from back from translations, when we had parentheses x plus 2, comma y, that meant that we were going 2 to the right when we were translating a point. So what do you think happens when we go from our original point 1 and reflect it over the x-axis so we get point 2? Compare the ordered pairs. Then we can look at point 1 in comparison to point number 3. That's when we reflected it over the y-axis. If you look at the ordered pair compared to the original, there is just one thing different. Again, that's both for x and y-axis. Okay, so here is our actual symbolic representation. Whenever you reflect it over the x-axis, if we reflect it over the x, it is the y value that becomes the opposite value. The x stays the exact same. So remember, we had 1, 3, and it translated then to 1, negative 3. And you could scroll back up and check that. Then if we look at when we reflect over the y-axis, again, our ordered pair was 1, 3. Now it was negative 1, positive 3. So the x value is what becomes the opposite. So whenever you are reflecting over an axis, the opposite value changes. So x-axis, y changes to the opposite. Y-axis, x changes. Now this is very important that you know that that is not a negative sign in front of the x or the y when we do the reflection. It is the opposite sign. So if I had the ordered pair 1, negative 3, and I reflected over the x-axis, then my new ordered pair would be 1, positive 3. Okay, remember that 2 negatives make a positive. Okay, so here for example 2, we're going to look at a parallelogram point. We are going to plot to the points given the coordinate plane. So part A is going to be at negative 1, negative 1. So that is right here, letter A. Letter B is at 2, negative 1. So I go to the right 2 and down 1. Then I have letter C, which is 4, negative 3. So I go to the right 4 and down 3. So this is letter C. And my last one is D, 1, negative 3. So I go to the right 1 and down 3 right here. And then I'm going to connect all of these with lines. There we go. Oops. There we go. All right. So now we are going to look at our pre-image, and we are going to reflect it over the x-axis. Remember that when we see x-axis, that means the y values are becoming the opposite values. Now, for me, I think it's much easier to just graph the points and then find them. For some of you, it might be easier to just do the opposite of y and write the ordered pairs and then graph them yourself. Totally up to you which way you decide to do it. For letters A and B, I'm going to graph them first. For letters C and D, I'm going to do the mathematical process. So for letter A, it is only one away from our x-axis here. This is our x-axis. So I know that my A prime has to be one away as well. Same thing with my B. My B is one away, so I know that it is going to go here. All right, so my new A value is actually -1, +1. And my new B, or my B prime, is now 2, +1. Okay, if you notice, it is just the y values that are becoming the opposite signs. Okay, so for C prime, if I look at it, I see that it's 4, -3. My 4 stays the same. My 3 becomes the opposite, so +3. So that means I'm going to go to the right 4, and I'm going to go up 3. And this is my new C prime. Same thing for letter D. If I look at it, I have 1, -3. So 1 stays the same. My -3 becomes the opposite, which in this case is +3. So I go right 1 and up 3. And this is D prime. Notice my shape did not change size, and it did not change the shape. What it did change is its location. It flipped or became a mirror image of the previous image. All right, this is going to be one that we are going to do together as well. We have vertices of 1, -2, 4, -2, and 1, 4. So 1, +1, -2. This is letter A. B is at 4, -2. And C is at +1, +4. If you look at these, or this shape, we notice it's a triangle. It's actually a specific type of triangle, which is a right triangle. So we have graphed the original image. Now we are going to perform this. This is the same as saying reflection over the y-axis. This is just in symbolic representation instead of saying verbally reflect over the y-axis. So what that means is that we are looking at our original A, 1, -2. The first number, our x, becomes the opposite, and y stays the same. We're going to do that for letter B as well. B, 4 becomes -4. Let me do that for you so you can see it better. -4, and then -2 stays the same because the y does not change. Same thing for letter C. -1, +4. Y does not change, x becomes opposite. So now I'm going to graph these points. A prime is at -1, -1, -2. A prime. Letter B is going to be at -4 and then -2. And then letter C is going to be on -1, +4. And this is doing the mathematical way. If you wanted to, you can see that A and C are both only one value away from our y-axis. The y-axis is that vertical axis. And so that's why A and C, the x values change, y stays the same. And B value is 4 away from the y-axis, so make sure that on the prime side, it is also 4 away from the y-axis. Okay, so when we are looking at these two, we know that these figures are congruent. We don't need to determine that. We need to determine what transformation actually happened. So I'm going to draw over this pre-image number 1, and we have to figure out what happened. We only know 2 types of transformations at this point. We know translations, meaning slides, and reflections, meaning flips. So if we look at triangle 1, we can tell that this is 2 values away from the y-axis. Over here, it's 2 values away from the y-axis as well. if we look at this point here, we can tell that same thing is that there we go. This point is 1, 2, 3, 4, 5 values away, and over on the left side, it is also 5 values away. So when we are noticing this, this is what we call a reflection. And you can tell that the reflection is across the y-axis, and that is because everything is changing opposite of the y. It's going to the other side. It's literally flipping over. Then, for letter B here, this one's actually a little interesting because it could be a reflection over the x-axis. It could also be a slide, so a translation. You can decide if this is a reflection or a translation. So for letter B there, if you decide it's a translation, that means that from pre-image 1 to to the final image, number 2, we slid up 1, 2, 3, 4, 5 spaces because this was right here at the bottom down here, and I went up 1, 2, 3, 4, 5 to put that point in the exact same spot. Okay, try to get this one. So when you are writing this, go ahead and write on line letter B. You can write that this was a slide or a translation. Five units up. Oops. Or, if you wanted to, you could say it's a reflection over the x-axis because it truly is. So it could be either one of those. Remember, if you need any help, to email me, and I'm more